And that's what climate change is about. It is literally, not figuratively, a clear and present danger.
We are in the beginning of a mass extinction.
The ability of CO2 to do the heavy work of creating a climate catastrophe is almost nil at this point.
The price of oil has been artificially elevated to the point of insanity.
That's not how you power a modern industrial system.
The ultimate goal of this renewable energy, plan is to reach the exact same point that we're at now.
You know who's tried that? Germany. 7 straight days of no wind for Germany. Their factories are shutting down.
They really do act like weather didn't happen prior to 1910.
Today is Friday.
Yes, indeed, it is Friday, you little climate zealot twit. We are going to be having a special roundtable today where we're going to be talking about global greening, which is why I'm in the background of the tropical forest. One of the things that is really bad about climate alarmism is the fact that they only focus on the bad. They never talk about the benefits. They never talk about how humanity is doing, in the face of these challenges that they say are going to destroy the world. Of course, it's all about bad for them. And it's all about doom. So we're going to talk a little bit about that. We're going to talk about the good side of things today. With us today is a different kind of a panel. Dr. Sterling Burnett normally joins us. He's off today on a special mission. And we have, of course, Linnea Lueken with us today. Dr. Will Happer also joins us, and he's going to be talking about carbon dioxide and some of its benefits and some of the issues related to it. We were scheduled to have Dr. Patrick Moore on today, and he has been technically unreachable for some reason. There might be an internet problem. We don't know. It's possible he may join us in progress. So we'll just go with the flow, so to say. First, I want to welcome Dr. Happer, and thank you for joining us today.
Thanks very much, Anthony. A pleasure.
So one of the things I want to get started off with is, the topic of global greening. And so we just recently published a brand new Climate at a Glance. And that Climate at a Glance at our website, climateataglance.com, talks about global greening. And that top graphic there is a picture of the globe, which is showing what's called NVDI, which is a vegetation differential index, and it's showing that much of the planet, except for parts of the Sahara and the Arab states, are pretty darn green. And of course, there's Greenland, which is not green and never has been, but except for the tiny portions of the coast. But this particular global greening summary talks about the fact that NASA satellites have been able, over the last 30 years, to determine that thanks to the fertilization of the atmosphere with carbon dioxide, which plants use for photosynthesis and for growth, we have seen basically an area larger than the United States, a surface area larger than the United States, increase in greenery. And we have seen places like the deserts, like the Sahara, start to shrink because plants are coming in along the edges now. And it's really a fantastic thing. The planet is sucking up this CO2 and enjoying it immensely, at least the plants are. And so this is a huge positive benefit that never gets reported in the media, never gets talked about by the climate alarmists, because, their whole agenda is about gloom and doom. We must do this to avoid gloom and doom, and the we must do this side of it is about control of you. So there's that. Also, I want to point out that in a timeline scenario of carbon dioxide over, millennia, we're in a much more interesting period. Let's go to this next graph, Andy. There it is. We're actually in a famine for carbon dioxide globally. Now, this graph here is from a study published in 2001 by Berner, and it was recently updated and displayed by one of our followers, John Shuchuk. But interestingly enough about this graph, it shows the parts per million of atmospheric concentration on the left and the timeline going backwards on the bottom. Today, we've got this blip going up to around 420 parts per million CO2 in the atmosphere. But compared to past millennia, it's nothing. It's nothing. It's just a blip. And so the optimum for plants, and people that know greenhouses, is in the 1,000 to about 1,400 parts per million range, and we're down around 420. That red line of death at the bottom, that is where there's not enough carbon dioxide in the atmosphere for plants to sustain photosynthesis. And look how close we've come to that, particularly a few thousand years ago during the Ice Age, when a lot of the plants got covered up by ice and photosynthesis wasn't happening. And, there was just we came close to having a plant extinction on the planet. And yet our climate alarmist friends would have you believe that, this increase in carbon dioxide that we've seen, which is just a blip in the whole scheme of things, is going to destroy the earth. It's going to destroy plant life. It's going to cause crops to fail, death and destruction raining from the skies related to weather. It's all bad. And so that's the preface of today's show. So first, I want to start off with talking with Dr. Happer. You've recently published some interesting papers on carbon dioxide and concentrations and climate sensitivity and all these sorts of things. Can you kind of give a little background of where you've been with that?
Well, I think very few people realize how ineffective CO2 is as a greenhouse gas for warming the earth. They talk about the increase of CO2 from 300 to 400 parts per million over the past 50 years or so. And very few people realize how tiny that effect is on Earth's climate. If you were to double CO2, say go from today's 400 to 800, how much do you think you would decrease radiation to space? You ask the average person, they've no idea. But I can tell you the idea, because this is my field, I understand this very well. You decrease radiation to space by 1%. 1%. And that's from a 100%.
That's all? Not more than that?
You get 100% increase in CO2, 1% decrease of radiation to space.
So
that's
basically that 1% translates to just a little bit of warming, right?
A little bit of warming. You can even do a calculation in your head of how much warming you would get from 1%. And let's do it now. Radiation increases very rapidly with temperature. To first approximation, it increases as the fourth power of the temperature. This is the famous T to the fourth law. It's not quite that, but it's pretty close. And so if there's a 1% increase, if there's a 1% decrease in radiation to space, that would mean the sun is heating us 1% more than we're cooling. And so to compensate, you have to increase the temperature of the Earth a little bit, to bring solar heating back into balance with radiation cooling. But you only have to increase the temperature by 1/4%, not 1%. So the radiation decreases 1%. That means you need a 1/4% increase in temperature. Okay, well, that's absolute temperature. Absolute temperature is around 300 Kelvin. 1/4% of 300 Kelvin is 0.75 centigrade. You can't feel 0.75 centigrade. It's 3/4 of a degree centigrade from doubling CO2. We're a long way from doubling CO2. So it's true temperature is increasing, but it's very hard to see that much of that increase is due to CO2. Some of it probably is, but most of it is probably the recovery from the Little Ice Age that ended around the year 1800, and it's been warming ever since. And
right, and of course, then there's our own local geoengineering of our climate. We build more infrastructure, more concrete, more asphalt, more buildings, use more energy, and so the thermometers are all near where we exist, where we live. Right? We don't have.
You're absolutely right, Anthony, and that's the famous urban heat island effect, which you've been so effective in demonstrating. And And as you know, if you look at really good stations that are not affected by the urban heat island effect, they show much less warming than these contaminated stations. So just getting good data is hard. And the reason it's hard is because the warming isn't very much. It's a tiny amount of warming. You can't feel the warming that we're talking about.
Yeah. Go ahead, Linnea.
Sure. So, Dr. Happer, and I'm not sure if everyone in our audience is aware of your background and everything. You're an atomic physicist, and your life's work has been in optics. And so, one of the major contributions that you've made to science is in adaptive optics, allowing us to see outside of the Earth's atmosphere. So, you have a very comprehensive understanding of atmospheric science. What kind of pushback, because I know you do get some pushback on your perspective on the climate issue from people who probably, aren't as deep into atmospheric optics as you are. And of course, anything that has to do with energy coming in and out of the atmosphere, that is what the climate change argument or the global warming caused by CO2 argument is based around. So if you want to expand on some of your own background and maybe some of the difficulties that you've had with people from your own field and maybe outside of it, I think that might be interesting to the audience.
Well, most of my colleagues at Princeton have been pretty good to me, and other parts of the physics community, and lots of physicists, secretly know that the alarm over climate is grossly exaggerated, but they're afraid to speak out. I can speak out because this came along as I was approaching retirement, and there's not much that can be done to my career now if I tell the truth. But that's not true of younger people. They will suffer. That's been demonstrated many times. I guess the only direct effect it's had on me is that it's very difficult to publish anything. As you say, this is my field, so I know a lot more about it than most climate scientists. But it's impossible to publish.
Right, because
I feel bad about the younger people who are associated with me. For example, I have a young colleague, William Van Weingarten, who is not as close to retirement, and this definitely is not good for his career, that he does lots and lots of good work, but he's unable to publish in mainstream journals. And there are other people like us. We're certainly not unique.
Well, and that's what part of what is so cynical and what's so cruel about the narrative that 99% of scientists agree, because they look at all these papers and they look for people who either just mention climate change in general or seem to be saying that human addition of CO2 is what's causing a lot of the warming. And if you're blocked from publishing for having a different perspective on this, then they're getting a skewed data set to begin with when they're trying to argue that most scientists agree with them.
Yeah, it reminds me of the Roman historian Tacitus, I guess, who was describing a speech made by Calgacus, after the Roman invasion of Britain. And Calgacus was trying to rally the few remaining British patriots to resist the Romans, and describing the Roman Empire, he says they make a desert and call it peace. They make a desert and call it peace, and that's what the climate establishment has done. They've simply, decapitated any opposition, and so nobody is able to publish anything that does not support the narrative. In mainstream journals, you can always find some journal that will publish it, but it doesn't have the weight, of the major journals. And that's completely deliberate. It's not accidental.
Well, yeah, the whole climate crusade is deliberate. It's about power and control, because if you can control energy, you can control everything.
Well, I've been appalled by the standard of stuff that does get published. This is stuff that's really not much more than, building a computer game practically and running it and then saying, look at how our computer game ran. Isn't this proof of what we're trying to say? And it's very disheartening to see the standard.
That's a good point, Linnea. We could build a climate computer game. And
we were supposed to be talking about the benefits of CO2, not about the physics of CO2. And I'm interested in benefits too. I grew up in a rural area, so I've always been interested, in how plants grow. And there's no question, as you showed in your introductory slides, that the Earth is greening. That's I don't know if you've looked into how they do those measurements, but it's really very, very clever. It turns out that chlorophyll, when it's illuminated by sunlight, actually doesn't use all of that energy, to make sugar or to make heat. It re-emits some as fluorescence in the near infrared. And so what they're looking at is the chlorophyll fluorescence. And that's not easy to see because you're looking down at the Earth, which is brilliant in the sunlight. You've got all this backscattered sunlight that has nothing to do with chlorophyll. It's coming from the sand, it's coming from the water. So the trick that they use is they look at the infilling of the D lines of the sun. These are dark lines where there's no light because of absorption, basically because of the greenhouse effect on the sun itself. But because of the fluorescence of chlorophyll, you can see the lines filling in. So I won't belabor this, but it's a very, very clever trick that they use on the satellites to make those images that you displayed. And everybody knows that CO2 benefits plant growth. There are lots and lots of commercial greenhouses that routinely pump in CO2. Anthony, you mentioned that you thought somewhere around 1,500 was optimum. That's really optimum for a greenhouse operator. Plants would like more than that. The trouble with the greenhouse operator is he has to pay for the CO2, so it's the usual business trade-off, what does it cost me to make CO2, and where is the sweet spot where I get the maximum profit? It's not what the plants would like. They would like more.
That's totally true. Yet, their plants thrived, back at the age of the dinosaurs, when we had 5,000 parts per million.
That's right. Yeah. And, to demonize CO2, to talk about carbon pollution, here we are, these participants in this conversation. We're made of carbon, life is based on carbon. When people used to talk about organic chemistry, they said it was the chemistry of carbon, the chemistry of life. And so, each of us breathes out, approximately 2 pounds of CO2 a day. Multiply that by 8 billion people, that's a lot of CO2 just from people being alive. And are we really polluting the earth? And, some people say, yes, we are. We've got to cut down the number of people. And
these are the people that say that we are polluting the earth are the people that are demanding that we make lifestyle changes. And, but it's also the same people that are completely hypocritical about it. People like Al Gore and John Kerry, who live lavish lifestyles, flying around the globe, lecturing to people, saying, you need to reduce your CO2 footprint. But really, it's only about you, not for me, because I'm special.
Yeah, that's right.
Well, and there was a study, I can't recall if we talked about this before on Climate Change Roundtable or if we talked about it maybe at one of our conferences, but that study that came up that was that showed that people who talk to their houseplants, when they're caring for them, or if they're singing or whatever, when they're caring for their houseplants, that the houseplants actually had a noticeable benefit to growth over ones that don't. And of course, non-scientists who looked at that, they were like, oh, well, plants are alive and they just like it that you're thinking about them, or whatever the argument is, some kind of hippie thing. But really what it is you're, breathing CO2 on them while you're nearby them. And
Oh,
that's
right,
probably has a lot
we're
more.
just talking about the large amount of CO2 you breathe out. Your breath,
Yeah,
40,000 parts per million. Plants love that.
yeah, of
Even
course.
diluted quite a bit. It's still a help to your house plant. So please talk to your geraniums.
So, Dr. Happer, I want to ask you a question about CO2 concentration. Now, one of them, I know this isn't about global greening, but you know what? We're going to do a free-form show here. Pretty much anything goes.
Yeah.
Back when we first started with the whole thing, back in 1988 with Dr. James Hansen, and he published his 3 different scenarios, they based their view of those scenarios or the models on climate sensitivity. Basically, what's going to happen to the temperature of the atmosphere for a doubling of carbon dioxide in it. Anyway, so my question is, why do you think that they're having so much trouble nailing down climate sensitivity? I mean, we've got observational estimates that are on the low end, a 0.5 degree to maybe 1 degree centigrade. And then we've got some of these computer models like RCP 8.5, which are showing 6 to 7 degrees centigrade for a doubling of CO2. Science has not been able to nail this down in over 30 years. Why do you think they're having so much trouble nailing down the real climate sensitivity?
Well, I think the basic problem is that they don't like the answer that the real climate sensitivity is less than 1 degree, probably, and they know that, that's the first thing you learn when you do a climate model, that the unfeedback sensitivity is around 1 degree or a little bit less. We just did a calculation in our heads that it's 0.75 degrees centigrade for doubling CO2. So these big figures require enormously large positive feedbacks that usually you say, well, okay, it does something to the water vapor distribution over altitude or does something to clouds, because water vapor and clouds are the main drivers of climate. It's not CO2. CO2 is, kind of a third-rate performer. Clouds are number 1, water vapor is number 2, and then comes CO2. So they've got to somehow amplify the effects of CO2 by factors of 4, 5, 6 to get the large sensitivities that you quote. Now, if you think about that's really very unusual. Most feedbacks in nature and chemistry, the natural world are not positive, they're negative. There's even a name for that. It's called Le Chatelier's principle. Go look it up on Google. And what people observe in most other systems is that if you change one thing to try and make something increase, that other things change in a way to resist that and to decrease what you would do without the feedback. So most feedbacks in nature are negative. And yet here we have this climate feedback that's hugely positive. It's not just a little bit, it's hugely positive. It's close to the feedbacks that you get on high explosives. And you sort of know that that's not true. The Earth has been around for 4 billion years, according to geological evidence. And there's no evidence that the climate has ever exploded. And there have been lots of excursions of CO2, big excursions. And there's never been any positive feedback to make the climate explode.
Yeah, well, a lot of that came from back in the early 80s when we saw the probes going to Venus and so forth, and people like Carl Sagan were out there screaming, that we may find the Earth go into a runaway greenhouse effect, and we've been, back in the age of the dinosaurs with 5,000 parts per million or more, and we didn't go into a runaway greenhouse effect. The whole thing is just preposterous. And yet, even today, we still have some people pushing this idea, and the media, which most of the media reporters are dumber than a post. They just follow whatever people tell them. They grab onto one particular thing and regurgitate it ad nauseum. They don't bother to investigate it. And so they'll even run with it. It's just really disappointing.
Yeah, you're right, Anthony. I mean, let's talk a little bit about Venus, because that's an interesting point. And frequently when I hear people debate from the alarmist side, they say, I don't want Earth to turn into Venus. Well, there are a number of things that are being glossed over there. First of all, Venus is quite a bit closer to the sun, and it therefore gets approximately twice the solar heating that the Earth does. So that's a big factor. That's 100% more sunshine. And so you would naturally expect it to be hotter. The second thing about Venus is, as a result of being closer to the sun, long ago, it lost most of its water. So Earth is the water planet. Venus probably had a lot of water too when the solar system was formed, but it was baked out by the sun, mostly because of the hydrogen dissociation. And so Venus has an atmosphere that's almost pure CO2, as you alluded to. It's close to 80 times the density of Earth's atmosphere. And the reason for that is there's no water to turn that CO2 into limestone. On Earth, most of the CO2 is not in the atmosphere or even in the oceans. It's in thousands of feet of limestone and dolomite, in the mountains,
what you make an interesting point about limestone. I am surprised that some crazy alarmist person hasn't come up with some kind of alarming scenario where the limestone is going to release all its CO2 and we're all going to cook.
Well, Anthony, I think that's part of the acidification argument, isn't it? That if there's a little bit too much ocean, if the ocean pH somehow goes to acid instead of base, that it will begin to dissolve limestone cliffs and stuff and
right.
coral reefs and
the cliffs of Dover are going to melt and roast England.
Yeah. No, it's amazing how much misinformation is out there and how much is believed. It's part of the problem is the poor scientific education that so many people get. And so they're easy targets. It's easy to fool them. They can't question it on their own. And so they have to listen. And in everyday life, you normally listen to the majority. And so the climate movement has done everything in its power to look like only a few kooks oppose the mainstream narrative, and the majority believes in it. And so this is the consensus argument that I think Linnea touched on briefly, and it's completely phony. It's science is not determined by consensus; it's determined by whether your theories agree with observation, and climate theories don't agree with observation, so they're wrong.
Every time consensus seems to have entered into science, it almost seems like it's almost always wrong. I mean, with Galileo, for example,
Right.
And the Earth is the center of the universe.
Right.
And then we had consensus about, medical issues related to the germs really didn't exist. It was other things, and washing your hands was a crazy concept before surgery,
Right.
that was a consensus and it was wrong. And then there was a consensus about more recently that ulcers were caused by stress, and an internist in Australia said that this is bogus. It has to do with this bacterium that's infecting the lining of the stomach. And the consensus was, well, the bacteria can't live in the stomach. It's too acidic. So this guy proved it by drinking this bacterium and gave himself ulcers. He ended up getting a Nobel Prize for it, but he bucked the consensus. And that's the whole thing with climate. Climate right now is about consensus. But the bottom line is that a history of science and consensus has been almost uniquely bad. It's never worked.
That's completely true, but it's surprising how many people believe that science is determined by consensus, that you get a group of sensible people together and they vote on what's scientific truth, and that's what the truth is. If you don't like the law of gravity, well, repeal the law of gravity. It makes life a lot easier, you can walk around a lot easier, so. But it's
certainly save fuel costs leaving the planet's surface.
That's right. Yeah.
Well, to get back to a little bit of the greening issue. So when I was in high school, the line was that the planet was undergoing desertification. So everywhere, all of the forests were dying. We were going to, because of the heat, we were going to have so much drought, so much terrible weather that the deserts were expanding. Well, it seems that objectively that's not happening. But what would happen if, like in a crazy hypothetical world where, I don't know, some other feedback didn't happen if you started to do this, if they really put the pedal to the metal on like carbon capture. Now, I'm skeptical that this could work anyway, because after we saw from the COVID lockdowns and stuff, there was almost no detectable movement in the amount of CO2 that was entering the atmosphere at all. And I think a lot of that has to do with the fact that the vast majority of it is coming from the oceans and whatever else. So, but what if they did start putting away carbon dioxide, taking it out of the atmosphere and putting it into whatever these cisterns are that they're trying to make for it? Do you anticipate that that could maybe have a bad effect? I mean, we were talking about that red line of death on the chart there, and I'm thinking, well, if you pull out even further onto like the billions of years scales, you can see that it seems like between every interglacial, CO2 gets a little bit lower. It comes back a little bit less. And it almost seems, and I think I've heard Dr. Moore make this argument, that if we had not started using fossil fuels, that there is a chance that it could have continued to decline and cause some real serious problems for life on the planet into the future. Now, I don't know if that's kind of abusing data or not, or if I'm misquoting, but I'd be interested to hear your perspective on that.
Well, there is pretty good evidence that at the last glacial maximum, when CO2 levels dropped to maybe 200, 180 parts per million, that there was plant starvation of CO2, especially at high altitudes. It's one thing to be at sea level, with CO2 at relatively high pressure, but if you're at a high altitude, you get a double whammy. There's not enough CO2 because of the low pressure, and you're also much more stressed for water because transpiration through the leaves is much faster at high altitude. So there's quite a bit of evidence that there was desertification of places like the Central Asia, Gobi Desert, Western US, places now where it's green, where simply rubble and stone and dust at the last glacial maximum. One thing you notice from the ice cores, for example, in Antarctica and Greenland, is that at the last glacial maximum, the ice is extremely dusty. There was very little CO2 and there's lots and lots of dust. So it was a time when there were worldwide dust storms that went all the way, from wherever they originate, probably closer to the tropics, to all the way to Antarctica. So I'm sure it was
like Mars or something.
we had a little bit of trouble with smoke this summer, from the Canadian wildfires. But during the last glacial maximum, that was the norm, and it wasn't smoke, it was dust,
Right. And that's not so crazy for people even today to picture, because even today you get a haze in Florida sometimes from Saharan dust making its way across the Atlantic. So that's not too out there for people to be able to grasp.
That's exactly right. Yeah. So I don't know. This whole thing is just so crazy. We've demonized this gas of life, carbon dioxide, which plants love, which is essential for life. And it's just astonishing that you could get away with that. I'm sure that 100 years from now, if humanity survives all of these attempts to save the planet, that there will be lots of doctoral dissertations written about how could people be so stupid in the year 2023 to believe all this nonsense. The same way we write now about the eras of witch burnings. How could people believe in all of that? But they did. And in our country, for example, the Salem witch trials, over half the judges had Harvard degrees, So it was not knuckle dragging ignoramuses who were driving the witch trials. It was the elite, the academic elite. That's sort of happening today. If you talk to the average American, they've got a lot more common sense about this and are a lot more skeptical, than the wine and cheese drinking elites of academia and, penthouses in New York and San Francisco and Los Angeles, maybe Chicago too. I don't know.
Yeah,
Well-
this graph here is one of the most important graphs for humanity related to carbon dioxide. Now, I want to point out that we have had tremendous increases in crop yields throughout the last 100 years, at the same time that carbon dioxide has been going up. Carbon dioxide is responsible for a portion of this, and we've also got, improved genetics, improved breeding practices to, minimize sensitivity to heat and to drought, and to provide better yield and things like that. So those all figure in, but one has to wonder, how much lower would a graph like this look over the past 100 years had we not increased the amount of carbon dioxide in the atmosphere?
Well, there have been many papers written on this, and they all agree that CO2 is increasing crop yields of every crop. It doesn't matter whether it's soybeans or wheat or corn, even sugarcane. That's a little surprising because corn and sugarcane are C4 plants, which are less sensitive to low CO2 than most plants. And but what they usually find is that CO2 causes the yield to increase by of the order of 1% or some fraction of a percent per part per million of CO2. So if CO2 is increased by 30% in the last 50, 100 years, you would expect about 30% of the increase in plant yield would be from CO2. As you said, there are many other factors that have been very important. There are better varieties, the massive use of fertilizer, especially nitrogen fertilizer, has been a very big deal. But CO2 has been part of it. There's no question that we would lose a lot of agricultural productivity if, as Linnea says, we extract the CO2 from the air, which is the craziest thing I've ever heard. I don't know where you would put it. And why would you want to get rid of this beneficial part of our biosphere?
Right. Well, and well, actually, a lot of it for that carbon capture stuff, they're talking about putting it into like rock reservoirs, the way that you would keep oil and gas for reserves. So, and as Sterling, if he was here, he could have gone off on this. It's probably a very bad idea to be doing that in general, but
It's an awful idea. It's a waste of money.
yeah.
And it's probably dangerous too. Every now and then these reservoirs leak. And, it's really true that if you breathe only CO2, if you're in a pure CO2 atmosphere, it will kill you. You suffocate. And that happens naturally from time to time. There was this famous
the lake in Africa.
In Africa, where this lake burped out huge amounts of CO2 and it killed thousands of people, lots of livestock. And that could happen with some of these geological reservoirs that people are talking about too. So this is really
CO2 is heavier than air. So if it under pressure coming up from the ground, it's going to spread across the surface. It's not going to disperse in the atmosphere.
That's right. It takes a long time to disperse. It eventually disperses, but it takes a long time.
Right. But, we have to store that CO2 to prevent the Earth from destroying itself. Anyway, so let's go to some of the questions that we've had. We had a number of questions pop up in comments. Let's bring up the first one and see what we've got. Chris Shattuck asked for Dr. Happer, what is your opinion of Frank's work on uncertainty and Ott Shula-Zong work regarding radiation versus conduction, which is the inverse of the IPCC 95/5% estimate?
Well, I'm not completely sure about the references you're making, so I'll try and wing it. Certainly, convection is dominant at this time of day. I'm sitting here at Princeton at around noon, and most of the heat transfer is rising hot air. It's not radiation at all. And so certainly during the daytime in the troposphere, convection is the major heat transport mechanism. That's particularly true when it's moist, because you're bringing up a lot of latent heat from the water vapor that's rising up. It eventually condenses into clouds and releases the latent heat several kilometers above your head. So people, I think, underestimate how important convection is. Once you get above the 30,000 feet, 35,000 feet, the tropopause, convection basically stops.
Mm-hmm.
So everything above that altitude is radiation.
Right.
But where we live, convection is a very, very important part of climate. It's the main part of climate.
So here's another question from Chris Nesbitt, and this is pretty important because this is basically the heart of positive feedback. Could Dr. Happer talk to us a little bit about the idea that the little bit of warming due to carbon dioxide causes more water vapor to evaporate into the atmosphere, therefore causing even more warming, i.e. a positive feedback?
Well, that's very roughly the cartoon picture of the positive feedback that IPCC uses. They dress it up with all sorts of sophistication. I don't think there's any evidence for that. We already talked about the geological record. If that were true, we're living on a water planet that's been a water planet for billions of years, and there's no evidence at all that there's ever been runaway climate, feedback. So, in fact, there are people who argue that the feedback from water vapor may actually be negative. Dick Lindzen, for example, has argued very forcefully that there is this iris negative feedback effect, that as you get more evaporation, more convection, clouds tend to form at lower altitudes. And that's quite important because it means the cloud tops are warmer than they were before. And so they're radiating heat into space actually more as a result of the increased convective transport of water. Because, the Earth basically acts a little bit like a, to an engineer or physicist, it works a little bit like a heat pipe. The troposphere, you've got all of this heat transfer by convection, and you carry all this warm air up, toward the troposphere. It has to get back down. What goes up must come down. What allows it to get down is its radiation into empty space with the help of greenhouse gases and cloud tops. And clouds cover about half the Earth, so cloud tops are at least as important and probably more important than greenhouse gases.
Yeah,
but
it's amazing how many people in the alarmist side of things don't understand the basic mechanisms of things like convection, Ferrel cells, Hadley cells, that kind of stuff. They don't understand how the atmosphere works. Their whole viewpoint is that carbon dioxide is essentially just causing hotness, and that's it, and the hotness is going to destroy everything. They don't really get into the details of how the Earth works. And here's the thing. The Earth has worked just fine for millions of years before we started worrying about carbon dioxide concentration. And It's likely to work just fine millions of years into the future, even, if carbon dioxide increases. It figures itself out. It's self-balancing, self-regulating.
It's also done the experiment with more CO2. You showed graphs right at the beginning of this session of the much higher CO2 levels in the past. And the Earth was just fine in those times. It was verdant, full of greenery and life. And so there is nothing unprecedented happening now.
Yep.
And anything that happens is more likely to be good, much more likely to be good than bad.
Right. Okay, so let's bring on the next question from our viewers. Bill Peckney asked, is anybody still challenging HITRAN? And before you answer that, you'll have to tell us what HITRAN is.
Okay. Well, HITRAN is this huge list of data on absorption of radiation by greenhouse gases. It was started at Air Force Cambridge Laboratory up, I think, in Hanscom Air Force Base many, many years ago, because many of these issues are very important to other people besides climate fanatics. You know, for the Air Force, for example, where I started getting interested in this, I was very interested in CO2, not because of climate, but because of the propagation of high power lasers. You know, if you try to propagate a CO2 laser through the air, you know, it gets all sorts of problems, thermal blooming and God knows what, due to the CO2 that's there. So the Air Force, to their credit, began and systematically studying absorption of atmospheric gases many, many decades ago. The people who did it are heroes. They should get a medal for it. And that's the HITRAN database. And they've added to it and added to it. And I've used it. Others have used it. I've checked it, you know, and in any way I can. And I think it's a very good database. There are parts of it that are better than others. You know, an example of where it's not terribly good yet is for things like halocarbons, you know, freons and things like that. There you can get some data, but the HITRAN people themselves say this was preliminary and don't take it too seriously. But for the main gases, for water vapor, for CO2, for methane, nitrous oxide, it's ozone is very, very good.
Okay. All right. Fair point. Thank you. So let's go to the next question and see what we have from our viewers. There we go. Dana Saylor asks, climate change may be front and center in the coming election. Any thoughts on how we may take advantage of the opportunity?
Well, I don't know whether it'll be front and center. My my experience working with politicians, and I've had a little bit of it, is that most of them don't want to touch controversial issues because they want to get elected, and they're worried that, for example, women Republican voters are worried about the climate, and so we might offend them and lose all of their votes. So I'm not sure how much mileage we can get out of this. You know, I think until the average person recognizes that, you know, the climate policies that are being proposed are really ruinous. They are doing no good. They're doing enormous harm.
Yeah, the policies are worse than the problem.
Yes. Then the politicians will shy away from it. They're just afraid that it'll lose them more votes than they will win.
Yeah, you know, and a good point of that is that it looked like a couple of weeks ago, President Biden might declare a climate emergency. There was, you know, a lot of talk about it. And we had, you know, predicted that he might actually announce a climate emergency on the island of Maui because of Lahaina burning down and all the early reports from the incompetent reporters out there that immediately jumped on climate change as the cause for the fire when it had nothing to do with it. And so here's the thing, he backed off from that despite tremendous pressure from environmental groups to declare a climate emergency. Biden backed off and didn't do it. And so that says something right there.
Mm-hmm. Well, it's the usual balance. I mean, his advisors that he listens to probably told him, look, Mr. President, you're going to lose more votes than you'll win if you do this.
Yep. All right, next question. CO2 increases usually lag temperature increases, yet we're seeing just the opposite now. I don't know that that's true. Could it be a different mechanism is responsible for increasing CO2 like the oceans?
Well, I mean, if CO2 increases are due to burning fossil fuels, and I think there's good evidence that that's the case, you would expect CO2 to go up first, and then it would go down a little bit because some of it gets absorbed by the oceans and by the land and various processes. So at present conditions where we think CO2 is increasing from burning fossil fuels, it's perfectly natural for it to lead.
Yeah. Hasn't history shown us, paleo history shown us, that there have been large scale global fires in the past?
Oh yeah. If all you have to do is visit Yosemite and look at the scars on the sequoia trees there. There have been horrendous fires, nothing like we've ever seen in the past. There was a enormous drought around 1200, 1300, 1400 all over the western USA. You can see these pictures of Lake Tahoe, which is practically a mud puddle at that time, and other lakes in that area that were hundreds of feet lower than they are today. There were trees growing on the bottom, which now are flooded by 100 feet of water.
Interesting. All right, let's bring on the next question. We have from Michael Johansson: a few physicists and astrophysicists have pointed out a problem with the greenhouse gas theory, where the incoming energy is divided by 4, resulting in a temperature of minus 18 degrees centigrade, which is far from reality. I think what he might be referring to is the fact that without the GHG effect, that we would have a temperature of the Earth that was essentially non-livable.
Well, let me try to respond. These would be much better conversations if it's just one-on-one, but the factor of 4 is from the fact that the area of sphere, the Earth is 4 pi r squared. R is the radius, and the area of a disk is pi r squared. So there's a factor of 4 between the area of the disk that intercepts the sunlight and the area of the sphere that you try to average it over. I never thought averaging made much sense, but that's what they do. So you're right to question the factor of 4. It doesn't make much sense.
It's the old joke of the physicist assuming that a cow is a sphere.
That's right.
That's what it is.
Exactly. That's a great joke. I'm glad you know it. Yeah. Yeah. I don't think any of these estimates mean very much, but people still make them.
All righty. So yeah, it's the point of all of this is that the Earth, its climate, its systems are all tremendously complex. And yet many of the suppositions and the predictions out there related to climate change are almost literally simplistic linear projections without taking in this vast complexity of the planet and its processes. And I think this is why we end up with all of these failures. I mean, modeling the complexity, as Dr. Judith Curry put it, is a wicked problem because there are so many factors, so many different things controlling how the planet's atmosphere behaves. I mean, we've got everything from water vapor to sunlight to clouds to albedo of plankton in the seas and nutrients and all this kind of stuff. It's hugely complex. And so trying to predict the future based on a system that is wildly chaotic and complex is basically an exercise in futility.
No, you're absolutely right. The hardest part of physics is really fluid systems, fluid mechanics, because everything is fundamentally nonlinear. Lots of other parts of physics are pretty linear, electromagnetic theory. If you're trying to calculate how to design a stealth airplane, that's completely linear. Quantum mechanics is linear for the most part, but fluids are not. There's a nice joke about that involving Werner Heisenberg, who invented, matrix mechanics, quantum mechanics, and he headed the German nuclear program during World War II. And as a result, after World War II, the Allied forces forbade him to work on nuclear physics. And so instead he worked on fluid mechanics, how does the atmosphere work and the oceans work? And he was appalled to find how difficult it was compared to quantum mechanics or nuclear physics. And so the joke is that one of his students said, well, Professor, they say that if you've lived a good life when you die, when you go to heaven, the good Lord permits you to ask 2 questions as a physicist, and he will answer both of them. And, what are you going to ask when it's your chance? And so supposedly Heisenberg scratched his head and he said, well, I'm going to ask why relativity and why turbulence? And I think the Almighty may have an answer to the first one.
Yeah.
So the point was that, fluid systems are too hard even for God. They're not,
Right.
but anyway, they're very difficult systems.
I wonder if Heisenberg ever met Schrodinger's cat. All right.
He knew Schrödinger very well.
Yeah.
Schrödinger moved to Ireland, and
Yeah.
there's
So
another-
we're out of questions for the moment. At least ones that are relevant to the discussion.
yeah.
So normally we do this at the beginning of the show, but we're doing it at the end of the show today. So Dr. Happer, stick around. We're going to show you a couple of the craziest climate things that happened this week. One of them happened in Nevada. This one was just beautiful. So we have the Burning Man thing going on in the Black Rock Desert of Nevada. And there's one road going into it, right? And so these climate protesters decided, hey, this would be a good target for us to push our agenda and block traffic to keep all those evil carbon dioxide spewing vehicles from reaching Burning Man. And so we have a video showing of what the result was.
The climate activists famous for shutting down highways and wreaking havoc on commuters might be hurting the environment far more than just people going about their every day on the road.
Take all of you out. You better move. You're gonna
Get out now! Get out! You can hear the shrieking. The video of Nevada tribal police blasting through a climate activist roadblock appeared to offer a unique satisfaction that comes with frontier justice, swift justice. But in that video, we missed something. The activists, the climate activists, backed up traffic for miles. Hundreds of cars and trucks and buses sat idling in the hot sun, burning fossil fuels and blasting air conditioning. It's the same thing that happens when climate protesters shut down highways in America's biggest cities. The stop traffic spews fog. In addition, it tends to inconvenience the people most affected by climate change. Working class Americans get the short end of the stick. They always do. They miss work and doctor's appointments. Of course, the Davos crowd still gets to fly their private jets around the world. And yes, protesters did spray paint a few yachts this summer in the Mediterranean, but let's be honest. That got washed off while their guests dined in Saint-Tropez. Nobody missed a dinner reservation. Bachungar Sargon is your opinion editor at...
Yep. That was it. Wasn't that beautiful? You know, the Nevada Rangers, I got to handle it to them. They said, we're not having any of this bullshit. And they just pushed them right out of there like they should because, you know...
I think this was Indian reservation, actually, Rangers. It was not the state of Nevada.
Oh.
So the message is don't mess with Indians.
Yeah. We're done with that.
Well, those activists were just trying to get all those cars to idle so that they can fertilize the desert with some good CO2.
Yeah.
And in the event, that kind of wraps up our show for today with that note. The lesson here is that if you play stupid games, you'll win stupid prizes. And that seems to be the whole focus of the climate alarmism debate today. We're winning stupid prizes on a daily basis thanks to these folks. Anyway, I want to thank you, Dr. Happer, for joining us today. Thank you, for Linnea, for your sparkling commentary. I want to thank all of our viewers for visiting and watching. I want to remind everyone to visit climaterealism.com on a daily basis, where we debunk some of the worst news stories about climate out there. climateataglance.com, which is the perfect reference point for which you can use to argue against some of this insanity, and energyatatglance.com, which is Linnea's website, where she talks about, the value of certain energies and the folly of certain types of energy operations as well. So I want to thank you all. And I would like to say, I want to wish everyone a great holiday weekend coming up, as we're going to have barbecues and people driving all over the place, spewing CO2, doing what they do. I'm Anthony Watts, Senior Fellow for Environment and Climate for the Heartland Institute, wishing you all a great day and a great weekend. Bye-bye.
How dare you!